Okay, I have started the recording. So, good morning, students. So today we're going to discuss about three-phase diagram only, and we'll derive some definition based on weight. Okay. So allow me to share my screen. Okay. Uh, can anyone please respond? Am I visible? That means my screen is visible or not?
Yes, sir.
Oh, okay. Yeah. Let's go to my drive. Geotech. I'll take model one. I think it should be weight relation, right? Okay, let me check. It is that's yeah. I think it will. This is the thing. Sorry. Wow. Yeah. So let me just open the PPT for soil as a three-phase system, part two. That is for relation in terms of weight. Okay. Uh, oh, sorry. Yeah. So it is visible, right? Okay. So in the last class, sorry. Let me mute my phone. Yeah. So in the last class, we already discussed about this diagram. I think it is familiar to you. This is simple schematic diagram representing a three-phase soil. Okay, that means this soil contain, you can see here, soil solid at the bottom, and above solid it will be water, and then above water it will be air. Okay, so I think these symbols are also you know identical also. I think you know these symbols. This V represents volume and W represents weight. Okay, let me allow oxygen. No, fine. Okay, yeah, so here you can see WS represents what? Weight of solid, or S stands for solid. You can also use small d for dry. Okay, so in some books you will see WD, so don't be confused. These WS or WD are same. WS represents weight of solid, W2 represents weight of dry soil, which is the same thing. Okay, and WW represents weight of water, WA weight of air, which is negligible. Okay, it is negligible and can be, it is so less that it can be negligible. That's why the total weight of the soil mass is comprises of only weight of solid and weight of water. Okay, it doesn't include weight of air. But in case of volume, it include all. That means all three component. If the soil contain three or in a three phase condition, that is V must be equal to Vs plus Vw plus Va, where Va plus Vw equal to Vv, that is volume of voids. Okay, now here weight of voice, if you want to say weight of voice is actually equal to weight of water. Fine. So I think it is already discussed in the last class. So let's move on to the next slide. Okay, how to, yeah. So the first a very important term, or a definition that I want to share with you, that is the term is your water content. Okay, you can see here water content or moisture content, same thing. Okay, so water content or moisture content, it is denoted by small w. It is look like capital W, but it is a small w. Okay, here in the symbol also you can see here small w. So what is this water content? So water content or moisture content, it is defined as the ratio of weight of water. Okay, it is defined as the ratio of weight of water to the weight of solid in a present in a given mass of soil. So from this mathematical representation also you will understand the small w, which is actually representing your water content or moisture content, is equal to what? It's a ratio of weight of water, that is w suffix small w, weight of water by weight of solid, ws. From the three phase diagram also you will understand. If you have drawn this diagram, you will get to understand very easily. Okay, and it is expressed in terms of percentage. So in this formula you can also multiply by 100%. Okay, so like this, let me X second. Mm, yeah, so you can use multiply by 100%. Okay, so since this water content um, expressed in terms of percentage, fine. Now a special note is given here. I think you can see here its value is 0% for dry soil and its magnitude can be exceed 100%. So what do you mean by this? So suppose the soil is a dry soil. Of course, now you'll know that for dry soil, water will not be there in voids, isn't it? That means the weight of water for dry soil will be zero. That means this water content or moisture content will be automatically become zero or 0%. Okay. Now its magnitude can be exceed 100% means what? It means that WW, that is weight of water, can be more than this weight of solid. Okay, and it is actually happen, or it can be seen especially in case of fine grained soil, especially some special clay soil we're going to discuss in coming classes. Okay, very small sizes soil particles are there in that particular soil which have a capability to hold water. Okay, that type of soil have weight of maybe have weight of water more than weight of solid. Okay, so in that case the moisture content or water content can be more than 100%, or you can say we cannot define the upper limit of moisture content or water content. It's a very important statement. So in some competitive exam, this some question may related to this statement may come. Okay, in different way. Okay, you just go understand these things. Okay, so after water content we'll discuss about unit weight and density of soil. Now I think you all know, we or you all know these things, what is unit weight and what is density. Now if I say for soil only, so what is unit weight in general? Unit weight will be what? Weight per volume. That means weight of soil by volume of soil. It will give you the unit weight. And what is density of soil? It is the mass of soil by volume of soil. It will give you the density of soil. Okay. Now first of all we'll discuss about the bug. Just for some time just ignore this. Number two we'll go proceed. Okay. Okay, just concentrate here at number 5. That is, you can see buck unit weight. So buck means what? Buck actually representing as a whole or in total. Okay, let me unlock the meeting. Yeah. So buck means as a whole or as total. That means what is the total unit weight of soil is how much. That is the actually meaning of buck unit weight. So bulk unit weight is a measure of, you can see here, it's a measure of amount of solid particles plus water per unit volume. That means what is the total weight divided by total volume? It will give you bulk unit weight. Simple is that. And it is denoted by gamma. Unit weight is represented by gamma. And if you are asking about bulk unit weight, that means total unit weight. So it will be come with a small t as a suffix. Gamma, small t. It is a small t, okay? Or simply you can write gamma. Okay, so gamma or gamma t, whatever symbol you can use, so it represents bulk unit weight, and it is actually how can you find out? Dividing total weight by total volume. Now for a particular, if you consider a three-phase soil, so what is the total weight of the soil? Ws plus Ww, that is weight of solid plus weight of water, since weight of air is negligible. Now, if you say total volume of the soil, it will be volume of solid plus volume of voids. In case of volume of voids, it's automatically included volume of water and volume of air. Okay, that means it's the this represents your total weight, and here it is represents your total volume. So total weight per unit volume, per unit total volume, it will give you bulk unit weight of soil. Okay, so it will be, it may be in kilonewton per meter. cube or kg per meter cube, the unit. Okay. After that, let's discuss about number 4, this one, dry unit weight. Okay. So now unit weight is common. Now new term is come here, dry. So if somebody asks you what is a dry unit weight, that means actually wanting, or it's actually want to know the unit weight of soil solid particle, because soil solid particles are actually taken as a dry. Okay, and since water and air separated out in three-phase diagram. Okay, so dry unit weight is a measure of the amount of solid particles per unit volume. So that means dry unit weight actually representing weight of solid, ws, weight of solid particle, not weight of soil. Okay, weight of solid per unit total volume. This v are same. Okay, so capital V, here you can also write capital V. Okay, fine. So dry unit weight, which is denoted by gamma d, small d, okay, as a suffix. Small d kya hai? Small d is representing dry. D for small d for dry. Okay, so gamma d is represented as ws by capital V, weight of solid by total volume. Okay, I think it is very simple to understand. Then we'll go to that number 1, where second, yeah, number 2. So this is your unit weight of solid or particle unit weight. Okay, here you can see the symbol gamma s, s for solid. That means it's asking unit weight of solid particle, not unit weight of soil. It's specifically asking about unit weight of solid. Okay, so forget about voids. If you are asking, if you are asked about a unit weight of solid particles only, denoted by gamma suffix small s. This s stands for solid, not s stands for soil. Okay, mind it. So how can you find out this? It can be found out by dividing weight of solid divided by volume of solid. Now you can see there is a change in denominator, that is, it is not divided by total volume. It is divided by only volume of the solid, not by the total volume. Okay, so if you divide volume of solid by, sorry, if you divide weight of solid by volume of solid, you will get the unit weight of solid. Okay, X second. Okay, somebody, Nivea, right? So it's okay if you have that problem. You will get this recording. You can visit your student portal. You will get this recording. You will just go through it. If you don't understand, you can just call me or WhatsApp me. Okay, don't worry. Okay, somebody please remember her name or roll number so that I can give her attendance. Okay, fine. Yeah, where am I? Yeah. So I think you have got these things right. Unit weight of solid. Unit weight of solid. Fine. Yeah. Now I'll come to this. Okay. You don't worry about this term. That is GS and gamma W. What is this? I'll tell you now. So I think for till now you have understand this. That is unit weight of solid is represented by dividing weight of solid by volume of solid. Fine. Now we'll come to this capital GS. Now what is capital GS? It is specific gravity of soil solid or soil grain. Okay. Now what is capital GS? Wait. Yeah. Specific gravity of soil solid. So what is specific gravity? So specific gravity, which is denoted by capital G in general, is defined as the ratio of weight of a volume. Sorry, it is defined as the ratio of the volume of a given volume. Sorry, X second. It is defined as the ratio of the weight of a given volume of soil solid at a given temperature. I'm again repeating, okay? Specific gravity is defined as the ratio of the weight of a given volume of soil solid at a given temperature to the weight of an equal volume of distilled water at that temperature. Okay, I think you have got, I think you are familiar with specific gravity. Oh? Okay, I'm just talking about a specific gravity. of soil solid particle only now. So what is specific gravity of soil solid? Denoted by capital G with suffix S for solid. Fine. So it can be defined as a ratio of unit weight of soil solid to the unit weight of water. Fine. It is not written here, but just concentrate on my line. That is, it is also defined as, that is, specific gravity of soil solid can also be defined as the ratio of unit weight of soil solid to the unit weight of water. Okay, now let's go back to that last slide. Here you can see this is what unit weight of solid. This gamma W represents unit weight of water. Okay, fine. So if you just rearrange this formula, the capital GS, that is specific gravity of solid, can be defined as the ratio of unit weight of solid divided by unit weight of water. So indirectly we can also find a specific unit weight of solid by multiplying unit weight of water with specific gravity of solid. I think you have got this right. So specific gravity for inorganic soil is varies from 2.6 to 2.8. Okay, so for most of the inorganic soil, it's the value ranges from 2.6 to 2.8, and it's a unitless. Fine. So after this, we'll go to the next. Wait. Yeah. Next, we'll discuss about saturated unit weight and submerged unit weight or buoyant unit weight. Okay. Now, what is saturated unit weight? I think you all know about this bulk unit weight. What is bulk unit weight? Total weight divided by total volume. Fine. Now, if the same soil is submerged in water, okay, if you just fill all the voids are filled with water, if voids are completely filled with water for particular that type of soil, for that soil the bulk density will be represented by saturated unit weight. Simple as that. Okay, saturated means the voids are filled with water. Now saturated unit weight is actually representing bulk unit weight, but you have to mind it that voids are filled with water only, there is no air. But when you say bulk unit weight, you may not be sure. In case of bulk unit weight, the voids may be filled with water, may be filled with air. Okay, but in case of saturated unit weight, there is a limitation. The voids must be filled with water. Okay, so it is denoted by this here. You can see here gamma SAT, gamma saturated. Okay, this gamma SAT, gamma sat is representation of saturated unit weight. Fine. Okay. Okay. So next, hang on. Let me drink some water. So next, your buoyant unit weight or submerged unit weight. Also, it is known as, sometimes it's also known as effective unit weight. Now, how can you find out submerged unit weight? So some submerged unit weight or effective unit weight will come in picture only in case of saturated soil or when the voids are filled with water. Okay, for this kind of soil, we can find out the effective unit weight. That means unit weight is related to your soil solid particles only, not with water. Okay, since water is a temporary part of the soil mass, it may come out of the system, which is permanent. That is soil solid particle. It will remain in that place. Fine. So buoyant unit weight or submerged unit weight is the effective mass per unit volume when the soil is submerged below standing water or below groundwater table. It's just a statement, okay? And how can you find out? You just concentrate on this mathematical term. Now, if you know for a particular soil, the saturated unit weight, which is denoted by gamma saturated, and if you know the gamma W, which is unit weight of water, and it sorry, it is a constant term. Unit weight of water, it is constant. It is 9.81 kilonewton per meter cube or 1000 kg per meter cube. It is constant term. So just what you need to do, just subtract unit weight of water from saturated unit weight of water. You will get effective unit weight of soil. Okay, if you subtract unit weight of water from saturated unit weight of soil, you will get effective unit weight of soil or submerged unit weight of soil. Understood? And now see uh, density. So we already discussed about till now we have discussed about different types of unit weight of soil. So what kind of what how many types of unit weight of soil we got? Say bark unit weight, dry unit weight, isn't it? Then this unit weight of solid or particle unit weight, isn't it? And saturated unit weight and submerged unit weight. Okay, so there are different types of unit weight we will can find out for a particular soil. Similarly, the same manner we can find out for the same type of soil we can find out density. Okay, like you can see here bark unit weight the same way bark density we can find out. Simply we need to replace uh, you know W by M for mass. Okay, we can find out bark density, dry density. Okay, then here density of solid, then saturated density and submerged density or effective density we can find out. All the other concept will be same. Only in place of gamma we have to replace by gamma by rho. I think you know these things. That symbol used for density is what? Rho. Okay, so just replace the symbol gamma by rho, you will, and the other formula will be same. Okay, so density is a measure of quantity of mass in a unit volume of material, where the unit weight is a measure of the weight of a unit volume of material. So density is a measure of mass and unit weight is a measure of weight present per unit volume. And density can be it both are interchangeable. Okay, so can be replaced by one by another other without harming the formula. Fine. I think you all know this. uh, Gamma equal to rho g, isn't it? Gamma means unit weight of water can be equal to density of water multiply small g. That is small g is what? Acceleration due to gravity, isn't it? So gamma equal to rho into g. The unit of density I think given here, usually we use gram per centimeter cube. Now do you know what is the unit weight of water, which is actually constant? Unit weight of water is constant. I already discussed with you, that is 1000 kg per meter cube or 9.81 kilonewton per meter cube. If you convert that term in gram per centimeter cube, you will get density of water, that is 1 gram per centimeter cube. Okay, so just remember this: density of water is 1 gram per centimeter cube, and unit weight of water is what? Unit weight of water is yeah, 9.81 kilonewton per meter cube or 1000 kg per meter cube. Okay, so next after this we'll discuss. Okay, tell me if you have any doubt till now, you can just respond me here. Till then I just drink some water then. Please respond in chat box. Do you understand till now? Yes or no? Just type yes or no. And if you write no, then just also type where you what you want to repeat. Please to respond. अगर समझ में आया है तो yes yes दे दो, नहीं आया तो no no दे दो. How to find saturated unit weight? Total weight divided by total volume. Simple as that. For a particular soil, if you can find out the total volume and if you can find out total weight, just divide total volume. Sorry, just divide total weight by total volume. You will get saturated unit weight. Actually, not saturated. It's called bark unit weight. If the soil is fully saturated, then the bark unit weight it will give a new name, that is saturated unit weight. Got it? Now we'll also discuss in coming classes how to find out how much water present in a particular soil. Okay, we'll discuss in coming classes how to find how much water present in a particular soil. We can find out in laboratory. Okay, there is a standard procedure that we can follow in laboratory. We can find out the water content in laboratory. After that, you can that's using the weighting balance weight machine. You can find out the weight. You can measure the volume. Okay, fine. So just go to the next last portion I have left. Next second, hold on. Okay, so I'll proceed to the next. I have left one slide only. Wait, can't get, yeah. So I'll discuss now at the last part of this class, that is some interrelation. So till now we have discussed about what different definition based on volume and different relation based on weights. So till now we already know about void ratio, porosity, degree of saturation, air content, percentage air voids, then specific gravity, isn't it? Water content, unit weight, density, different types of unit weight, different types of density, isn't it? Fine. So uh, we can use this all relation to solve some problem or to find out the characteristics of a particular soil. Fine. So using now see here you can see some correlation or interrelation. How many? 1, 2, 3, 4, 5, 6, 7. Okay. So I at least advise you to at least go try to remember first, second. Okay, this one, and yeah, this. Okay, it's better to memorize these things. Okay, now this first relation is about what? It is the relation among this small w represents what? Moisture content or water content. Small w, capital S is what? Degree of saturation. E for void ratio, and capital GS, specific gravity of solid. Okay, and these are actually intermediate term. You can go through this intermediate term how you reach this, but or anyway you just try to remember directly W equal to SE divided by capital GS. Okay, or you can just go through this definition how actually it's reached. Okay, so by definition is W water content is what? Weight of water by weight of solid. By this it can be break down by like this, then it can be break down by like this, and then finally it will reach here. Okay, so it is a this first relation is very important and is relation among water content, degree of saturation, void ratio, and specific gravity. So it is like Es equal to Wg. Okay, next one for unit weight of soil, or this can be represented in terms of density also. So unit weight of soil can be represented by this formula: specific gravity of solid plus degree of saturation multiplied by void ratio whole multiplied by unit weight of water divided by 1 plus void ratio. And this can be also be represented in terms of porosity. Porosity means small n. I think you remember these things. So you also know there is an interrelation between small e and small n that we already discussed in the previous classes. Okay, so void ratio can be find out if you know for a particular soil, if you know porosity for a particular soil, and vice versa. So E can be represented by N. So this whole expression can be represented in terms of porosity also. Till now we have used only void ratio here. Okay, from this bulk density or bulk unit weight, you can find out dry density of soil. Okay, now how can you find out dry density of soil? Just put S equal to 0. Now you know in case of dry soil, degree of saturation will be 0 since there is no presence of water. So if you put 0 here, what will happen? this term will, it will neglected. Okay, so simply directly gamma w into capital gs by 1 plus e. So you can see this formula, dry density, oh sorry, dry unit weight can be represented as specific gravity of solid multiply unit weight of water divided by 1 plus e. Okay, so yeah, density of dry density of soil or dry unit of soil can be represented in terms of density also. So dry density of soil can be, or dry unit weight of soil can be represented by this formula also. How can you find out? Just divide bulk density by this one, actually bulk density of soil divided by 1 plus w. Okay, if you go through mathematically you will also get the same result. So dry unit weight or dry density can be derived by this formula. Okay, same way this one also, one of the important formula here. This all these three are just a modified formula, and it's coming, the original formula is this one. So try to remember this general formula for dry unit weight or dry density. Okay, these two are first and second are very important. From this you will find out the other modified uh, you know other modified formula you can derive. Okay, and other three, these two also you can just try to remember, this one also very important. Okay, so that's all for this first class. So till now, do you have any doubt? You can ask me. Okay, I'll do one thing. I'll just stop my recording now. Okay.